These notes are from Tuesday, February 28th, the day that the juniors were taking the ACT, or Wednesday, March 1st if you're in 6th hour. Okay, we talked about the heat of something. We can calculate the heat change by taking the mass of the object times the specific heat, which is how well it heats up or cools off, times the temperature change. Well, you can also, if you know the temperature that something lost, you can set that equal to the temperature that something gained, and you can do calculations with that. So that's what we're going to talk about. When you have two different temperatures, heat flows from the material at the higher temperature to the material at the lower temperature. The amount of heat lost by the hot material equals what's gained by the cold material. Now, this picture's wrong. In this case, the metal is losing heat, so the metal should be negative, and the water should be positive. So if the surroundings are the water, that should be positive, and if this is the metal, that should be negative. Okay? So that's what we're going to do. The handout that they got on that day, this Q equals Q. Again, we're going to change our signs up at the top. The metal lost heat, the water gained heat. And this is from the gizmo. The gizmo, we had a substance, then we knew the starting temperature, we knew the ending temperature, and we knew the mass. It didn't tell us copper's specific heat, though. But we know that the copper lost energy and the water gained that energy, and they should be equal. So we can actually calculate copper's specific heat. By doing this, what we're going to do is we're going to take the mass of the metal, because I'm going off of this. The mass of the metal is 200 grams. The specific heat of the metal is unknown. We could look it up, but we're going to calculate it. And our temperature change is from 90 to 34.96. Now, I should do that the other direction and come up with a negative number, but we're just going to set them equal. We're not going to worry about who's gaining and who's losing for right now. Okay? That would be equal to the mass of the water times the specific heat of water, 4.184 joules over grams degrees Celsius, times the final temperature, 34.96 minus 30. Okay? So, let's, I don't know what they say in math. Let's do the math. Combine like terms, I don't know, 90 minus 34.96. Let's try that again. 200 times 90 minus 34.96. I get 11,008, and our units are going to be grams times degrees Celsius, and that will be times the specific heat. And we're going to set that equal to 200 grams of water times the specific heat of water, 4.184, times the temperature change of the water, which is 4.96. And when I do that, I get 4,100. This doesn't seem right. Let me see if I did my math wrong. 4,146.6. I guess that was a smaller temperature rise, so that's why. Okay, and this is grams cancels, Celsius cancels, so our answer's in joules here. Now we want to solve for specific heat, so we're going to divide both sides by 11,008. Okay, 4.4146.6 divided by 11,008 gives me specific heat of 0.377 joules over grams degrees Celsius. Okay, when we look up copper specific heat, it's actually 3.385 joules per grams degrees Celsius. So that's pretty close. Now we'll calculate granite. Granite, we also had 200 grams. We also are solving for specific heat. And the temperature change for granite was from 90 to 39.59 degrees Celsius. We set that equal to the 200 grams of the water times 4.184 joules over grams degrees Celsius times 39.59 minus 30. Okay? Okay? So the water gained 8,000 joules of energy. If we divide that by the mass and the temperature change combined, we'll cancel that guy out, and our specific heat is going to be 0.796 joules over grams degrees Celsius. We can look back at our notes. And for some reason, it keeps going back to the start. Sorry. And here we can see granite, the value in the notes was 0.79. So 0.77, pretty close. Now, 0.795, is that what we just calculated? That's spot on. That's really good. All right. 0.796. I'm down with that. All right, so let's try lead. See how close we get on the lead. We had 200 grams of lead times specific heat of lead, and the temperature change for the lead was 90 to 31.75. And then we're going to set that equal to 200 grams of water times 4.184 joules over grams degrees Celsius times 31.75 minus 30. So we get 200 times 90 minus 31.75. 11650 grams degrees Celsius times specific heat is equal to 200 times 4.184 times 31, no, just 1.75. Four, 4.4 joules. Divide both sides by 11650, and we get 0.126. If we look at our lead and watch, I'm going to have to, oh, it stayed. Lead was 0.128, and we just calculated 0.126. Again, I'm good with that. That's pretty good. Okay, one more problem. This time we have an unknown piece of metal. We know his mass, so remember we're going to do Q of metal equals Q of water. The mass of the metal is 23.8 grams. We don't know the specific heat because we don't know the metal. The temperature starts out at 100 and it ends at 32.5. That is going to be equal to the mass of our water. Now this time it gave us mass, it didn't give us mass, it gave us milliliters. but 1 milliliter of water has a mass of 1 gram. So if we have 50 milliliters, we have 50 grams of water. Specific heat is 4.184 joules over grams degrees Celsius. And our temperature change here is 32.5 minus 24. So 23.8 times and I got for specific heat 1.11 joules over grams degrees Celsius, which doesn't happen to be a choice in the notes in that list. So we still don't know what the metal is. Okay? There you go. That is basically what we went over on that day. The rest of the time, the kids had to work on the first 3 pages of the review for the test you're taking next week, Wednesday the 8th and Thursday the 9th of March. Thank you.